Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. Now in the MCQ series, let us discuss about the MCQs on shear force and bending moment diagram of the subject strength of material or mechanics of structure. Without wasting the times, let us start with the questions. Question number 1. A point in shear force diagram where shear force changes its sign is called as A. Point of shear, B. Point of inflection, C. Point of contra shear, D. A and B both. Now, in the shear force diagram, there is a point where shear force changes its sign. At that point, the shear force before the point and shear force after the point are of opposite signs, hence they are contradictory, hence it is known as the point of contra shear. Hence the correct answer is C, point of contra shear. Question number 2. Bending moment is always maximum where shear force is A. minimum, B. maximum, C. changing its sign, and A and B both. Now here, wherever shear force is changing the sign, bending moment is always maximum. Okay, so the correct answer is C, changing its sign. Question number 3. For a simply supported beam with double overhang, nature of bending moment at support is A. hogging, B. sagging, C. A and B both, D. none of the above. Overhanging beam, the support extends beyond the support. Okay, beam extends beyond the support, that is known as overhang. So due to overhanging portion which acts as a cantilever, it bends as hogging. Okay, therefore the correct answer of this question is A, hogging. Question number 4. A simply supported beam of span L carries a downward point load W at the center. The maximum bending moment carried by the beam is A. WL by 2 hogging, B. WL by 4 hogging, C. WL by 2 sagging, and D. WL by 4 sagging. Now, in this question, this is a standard case of simply supported beam carrying a point load at center. The maximum bending moment is WL by 4 sagging. Hence, the correct answer is D, WL by 4 sagging. Question number 5. A simply supported beam with single overhang carries a point load W at the free end of overhang of length A. The direction of reaction at the other end is A. acting upwards, B. acting downwards, C. neither A or B, D. both A and B. Now in this question, a simply supported beam is having overhang on one side. If you say that a beam ABC, it is supported at A and B and C is free. If the load is applied at C and that load is acting downward, then it will try to press the beam downward. Therefore, end A will try to lift up. Therefore, the reaction at A will be definitely acting downward. Hence, the correct answer is B, acting downwards. Question number 6. A simply supported beam of span 9 meter is subjected to 2-point loads of 20 kN each at 3 meter from each end. The bending moment under each load is A. 90 kN meter each, B. 20 kN meter each, C. 60 kilonewton meter and 80 kilonewton meter, and D 60 kilonewton meter each. Now in this question, this is a beam of span 9 meter. If you divide this span 9 meter in 3 stages, 3 meter, 3 meter, 3 meter, and each load of 20 kilonewton is acting at 3 meter from right hand and left hand. So loading is symmetrical and loads are also equal. So each reactions will be 20 and 20, and therefore if you take under the load on one side of the section only 20 kilonewton will be there, and 20 into 3, that will be 60 kilonewton. So each bending moment will be 60 kilonewton. Hence the correct answer is D 60 kilonewton meter each. Question number 7. A simply supported beam of span 5 meter is subjected to a point load of 50 kilonewton at 2 meter from left hand support. The magnitude of bending moment under the load is A 60 kilonewton meter, B 30 kilonewton meter, C 20 kilonewton meter, and D any other value. This is a simply supported beam carrying a point load not at the center, and the maximum bending moment in this case is WAB by L, where W is 50, A is 2 meter, B is 3 meter, L is 5 meter. If you put all these values, it will be 50 into 2 into 3 divided by 5, and the answer will be 60 kilonewton meter. Hence, the correct answer is A 60 kilonewton meter. Question number 8. A cantilever beam of span 4 meter is subjected to a UDL of 20 kilonewton meter over the entire span. The maximum bending moment due to load is A 90 kilonewton meter, B 120 kilonewton meter, C 160 kilonewton meter, and D 140 kilonewton meter. This is a cantilever carrying a UDL on entire span. The maximum bending moment is standard case WL square by 2. So 20 into 4 square, that is 16, divided by 2, and it will be 160 kilonewton meter. Hence the correct answer is C 160 kilonewton meter. Question number 9. The relation between shear force and rate of loading is A dF by dx is equal to 0, B dF by dx is equal to W, C dF by dx is equal to F, and D dF by dx is less than 0. Now here is the standard relation between shear force and rate of loading, which is the rate of change of shear force is rate of loading. Hence the correct answer is B dF by dx is equal to W. Question number 10. For a portion of length 2 meter of a beam, the shear force changes from minus 10 kilonewton to plus 6 kilonewton. The intensity of UDL in kilonewton meter per meter acting on that portion is A 2, B 8, C 4, and D none of the above. Now in this question, this is the question based on the previous question, that is the relation between shear force and rate of loading, that is rate of change of shear force is equal to rate of loading. Now at 2 point shear forces are given, you have to find out the difference of them. So it will be 10 minus 6, that is 10 plus 6 is 16, divided by length, that is 2, and it will be 8 kilonewton per meter. Now mind well, even if it is minus, as it is acting downward, it comes as minus. So actually the relation is dF upon dx is minus W. So it will be minus. Okay. So the correct answer in this case is B 8. That is 8 kilonewton per meter. Question number 11. In between 2 points on a beam, if the bending moment is constant, then A the shear force between those points is 0. B, the shear force is constant. C, the shear force is maximum. And D, the shear force is minimum. Now, this is the question based on relation between bending moment and shear force, which is the rate of change of bending moment is shear force. That is dm by dx is equal to F. Okay. So here it is given that in between 2 points bm is constant, and therefore dm by dx. Okay. So dm by dx you have to calculate, that is constant, and derivative of constant whose derivative is constant is 0. That means the shear force in that region is definitely 0. As shear force will be 0, then the bending moment will be constant. Okay. Hence, the correct answer of this question is A. The shear force between those points is 0. Question number 12. For a simply supported beam with single overhang, the point where nature of bending moment changes is called as A. Hogging point, C. Point of contractile shear, C. Point of contraflexion, and D. None of the above. Again, here the change in its nature or change in its sign is contra, and as it is for bending moment it is flexure. Hence the correct answer is C. Point of contraflexure. Question number 13. The relation between shear force and bending moment is A. dm by dx is equal to 0. B. dm by dx is greater than 0. C. dm by dx is equal to F. And D. dm by dx is less than 0. Just now we have solved a question on that. Here rate of change of bending moment is shear force. Hence the correct answer is C. dm by dx is equal to F. Question number 14. A simply supported beam of span L carrying a central point load W has a maximum shear force of magnitude. This is a standard case simply supported beam carrying a point load at center. The maximum shear force will be the reaction, that is W by 2. Hence the correct answer is C. W by 2. Question number 15. A simply supported beam of span L carrying a UDL of W per meter has a maximum bending moment of A. WL by 2, B. WL square by 3, C. WL square by 2, and D. WL square by 8. This is a standard case of simply supported beam carrying a UDL on entire span. The maximum bending moment is WL square by 8. Hence the correct answer is D. WL square by 8. Question number 16. A simply supported beam of span L carrying a UDL of W per meter on entire span. The nature of bending moment curve is A. Triangular, B. Hyperbolic, C. Rectangular, and D. Parabolic. Whenever UDL is acting on the beam, the general equation is of second degree. Hence the nature of the curve is parabolic, and the correct answer is D. Parabolic. Question number 17. At a point in a shear force diagram where the shear force changes its sign, the bending moment is A. 0, B. average, C. less than 0, D. maximum. We know that the point where shear force changes its sign, bending moment is maximum. Hence the correct answer is D. maximum. Question number 18. A simply supported beam of span 6 meter carries a downward point load of 60 kN at 2 meter from left end. The maximum bending moment carried by the beam is A. 360 kN meter, B. 80 kN meter, C. 40 kN meter, and D. 60 kN meter. Here the maximum bending moment is WAB by L. Put the appropriate values, you will get the answer as 80 kN meter. Hence the correct answer is B. 80 kN meter. Question number 19. For a simply supported beam carrying downward loads, the bending moment is always 0 at A. Center, B. Supports, C. Under the point load, D. Any other point. For a simply supported beam, the bending moment is always 0 at the supports, hence the correct answer is B. Supports. Question number 20. For a cantilever carrying downward loads, the bending moment is always maximum at A. Center, B. Fixed end, C. Free end, and D. Any other point. For a cantilever carrying downward point loads, bending moment is always maximum at fixed end, and the correct answer is B. Fixed end. Thank you.